Here we are at the my favorite booth actually, the SUSE booth. Great sense of fun here and great giveaways. So I'm very excited to speak. My name is John Friesen. I don't work for SUSE, but I'm very fond of SUSE for reasons which you will find out, because my company, Nimbl, we run SAP in the cloud for customers. So we're a hosting company, and we were very early adopters of AWS and running SAP in the cloud. In fact, we were probably one of the first. We were running SAP workloads in 2009, first production workload in 2011. It wasn't even certified as a platform yet, but you could see which way the winds were flowing. And when I was launching our hosting practice, my wife said, "Okay, are you going to start building out a data center and raise floor and all that stuff?" I said, "No, those days are over. No one's going to do that anymore 5 years from now." We were way ahead of the curve. But for reasons that are probably obvious to everyone here, running SAP in some cloud, any cloud, is the best place to run SAP. I believe that sincerely. I don't work for AWS, I don't work for Azure, I don't work for SUSE. I'm just a guy who has to run SAP systems and make sure they never go down. And our practice, we do remote basis administration for customers who have systems on premises, and those systems go down all the time. Someone messed up a firmware patch on the SAN, or they tripped over a power cable, or we've had everything in the world happen. Meanwhile, the stuff that runs in the cloud, I can sleep quietly and peacefully. So I'll talk a little bit today about running systems in a robust fashion in the cloud, which is probably on everyone's mind when you're going to the cloud. My background, I'm very enthusiastic about this topic. I've been in the managed services industry for 25 years now, so I was never a consultant. My job has always been running systems for customers. What happens after go live? How do you keep a system stable? How do you keep the customer happy after go live? So that's my particular discipline. Let's see if I can get this thing to go here. Uh-oh, I might have to hit the keyboard. All right, beautiful. We'll be talking about, let's see, did I miss it? Let's see, did I miss something? Here we go, yeah, right. We'll be talking about the layers of applications here. I'm going to be talking mostly in the context of AWS, but this all applies to Azure, this applies to Google, they all work about the same. You've got the infrastructure component. What is infrastructure anyways? Anyone ever work in a data center? Yeah? So you felt the chilled air vibrating with the power of 100 air conditioning units. You've got kilowatts per square feet, and you've got rack space and so forth. These are the capacity issues that someone working in a data center has to deal with. That's all been abstracted away in the cloud. There's no such thing as capacity management anymore. Now it's cost management. You will not consume Amazon's capacity. I used to be like, oh, we got a customer with a 10 terabyte database. Amazon laughs at your 10 terabytes. If it's not exabytes or what's above an exabyte, a zettabyte, they probably, you're not going to get their attention. Anyways, that's all abstracted away. The network part is all abstracted away, so that spider web of cables between the different systems, all abstracted away. And then you've got compute, storage, database, the classic computer components, and the application services. So when you're running a cloud service like we are, what we're doing is providing on top of the AWS layer, because AWS doesn't really care about SAP, they're just giving you virtual machines. Then you've got the managed services on top of that. What would managed services for an SAP system be? It would be things like your quarterly kernel patch, because you're going to keep your kernels patched, right? Because you don't want the bad guys. There's a big vulnerability announced recently. Kernel patches, support packages once a year at least. SAP wants it twice a year, but let's be real. You've got your daily checks, you've got your automated monitoring, job scheduling, user management, all that kind of stuff. And finally, the really important stuff, backup and restore, disaster recovery, etc. So this all becomes a set of managed services layered around the Amazon component, and then you've got SAP running in a turnkey scenario from top to bottom as a single managed service. Why do we use SUSE? So here we are, we're engineering a cloud hosting service. Why use SUSE Linux? Anyone here use SUSE Linux? Are you all users? You come back to praise them for their good work. I don't want to be a partisan. Red Hat's cool too. Linux in general is awesome. But SUSE, why is SUSE our preferred flavor. If a customer doesn't demand something else, we go for SUSE. Why? Because they're deeply in bed with SAP, like they know they've been the first certified for HANA, et cetera, et cetera. And they have some really interesting features that are interesting to a service provider. Talk to the guys at the booth here about their live patching feature. You can patch SUSE Linux without downtime. And we have some customers who make us host their systems on Windows, and guess what? We have to have a monthly downtime to patch those security patches that come out every Patch Tuesday by Microsoft. I don't have to bring the system down for SUSE. So as a service provider, the last thing I want to do is schedule with the customer, hey, when can we bring your system down? Oh, 2 a.m. on a Saturday? That's great. I didn't need to sleep anyways. So live patching changes the life of the service provider, and it changes the life of the customer too, because they don't want to talk about downtime. They're running in the cloud. It's supposed to run all the time. It's just supposed to magically run. So live patching, killer feature. High availability features, which I will touch base a little bit on, but talk to them about the booth here. They have a very innovative approach to running SAP in an HA kind of fashion in Amazon. And I can tell you, having seen the hoops they had to jump through to make it work, that the classic clustering techniques don't always apply in the public cloud, but they got it to work, so it's pretty hip. So they took the existing SUSE clustering features and made it work in the public cloud. And ease of administration. Now, that sounds like a silly thing to add, the ease of administration. So those of you who've used SUSE Linux, you know about YAST, right? There's YAST, I don't know how to pronounce it, but I know how to run it. And this is actually really a legitimately material feature for a service provider, because it means if I can have some mid-level people do something that maybe would have required a senior guy, but now they can go through a menu and it'll be done right every time. That makes a difference for everyone. Stuff done right the first time, happy customer. Done by maybe a mid-level person instead of a senior person. Now the senior guy is free to work on more value-add stuff. So that makes a material difference for us. And on that topic, just want to share a little bit of a dream with you here for a second. Let's just talk about how things have progressed for us. Are you all system administrators here, IT guys? Yeah. So let's think about what has happened to our jobs over the last decades. When I got my start in the mid-90s, I was really lucky. I got to work in a place where I got to do the whole thing from soup to nuts. Unbox the Sun server, brush off the styrofoam peanuts, rack it into a server, install Solaris, plug it into the storage, plug it into the network, configure the firewall, install Oracle, install SAP. You got to do it all. And what's happened is, over time, we've had this bifurcation in IT departments, so that, okay, well, the basis guy is not allowed to touch the database anymore. That's got to be a database guy. And no one's allowed to touch the storage anymore. It's going to be a storage administrator, because, of course, SANs are complicated. You do something wrong and you've whacked everything. Servers, of course, have to be run by, built by the server team and so forth, with hands on the servers. And so we've had this increasing number of silos in IT. You can't get anything done. You try to provision a new SAP system for your project. Now you've got this flurry of tickets with 10 different departments. And is everyone going to type everything right into the ticket? No, there's going to be a confusion. Someone's going to do it wrong. Now you have to do rework. So my sincere hope is that the public cloud, with the simplicity that it brings, is going to change the mindsets in some IT departments. I mean, I've seen customers go to the cloud where they say, well, the network guy can push the button that does the network thing in Amazon, and the storage guy can push the button for the storage, which is not the right, that's taking 1990s org structures and trying to apply to the public cloud. This simplification is an opportunity for all of us as system administrators to get things done and break through some of those barriers. So in our organization, here we are, a service provider, trying to be agile for customers, trying to get things right the first time. Well, I'm an old Unix administrator, and in Unix, you do something once, you do something twice, and then you script it. And the public cloud, Azure, Google, Amazon, all of them have APIs, so you can have your cloud expert script the perfect provisioning process, and now anyone can run that script and have a perfectly provisioned system. So when we sign a contract for an SAP hosting deal, I can have someone running SWPM in a system to install SAP 15 minutes after contract signing. And we usually get the dev system to the customer within a week of contract signing. Backups, monitoring, the whole 9 yards ready to go. And our goal is to bring that down to a day after contract signing. This is all possible because of the increasing simplicity brought to you by the public cloud. So my plea to you is to talk to your bosses, influence your organizations, and somehow influence your auditors too, who sometimes, when it comes to segregation of duties, they're not always on the right track. I think we can improve the way we deliver IT. Okay, that's just my, it's not even on today's topic. I just want to share that with you. Okay, fine. Let's get to today's topic. I've pontificated here. Let's talk about high availability in the cloud. We're going to go through the layers of possible failure. Of course, when you're engineering anything in the cloud, you have to engineer it with the assumption that things are going to fail. Now, I would say our experience with the public cloud has been very positive. Very few unplanned outages. Actually, we've never had a production unplanned outage in 7 years. But you have to engineer for failure. Why? Because these cloud providers do not provide an SLA, or not much of an SLA. On a specific server, they're not going to say, well, this VM is going to be up 4 nines, 5 nines. They're never going to do it. So you have to assume that they're going to be shutting down VMs, or something's going to catch fire, or maybe they'll just decide to do maintenance on a router. So everything has to be engineered for redundancy. So that's the approach we have to take. We have to look at the components and engineer for redundancy. So let's just go through real quick what an SLA is based on. If you're offering your business an SLA, so you're going to say that we promise that ERP is going to be up 99.9% of the time, that's 3 nines. It means you have to recover from a failure in 43 minutes, less than an hour, to meet what I would describe as a fairly modest SLA. And it goes up from there. If someone says, well, I can keep my system up with 4 nines of availability, that means they can recover from any failure in under 5 minutes. So it requires some automation, and if you're going to go for 5 nines, that means sub-minute recovery, then honestly, I haven't found a public cloud solution that can offer that at the application level. Of course, they'll say, yeah, we give you 5 nines, sure, at the infrastructure layer, but you're not bringing up HANA from scratch in sub 1 minute, not yet anyways. Fine, so I'm going to talk about, this is going to be Amazon-oriented, but similar concepts for Azure and Google. First layer that you're trying to protect is the overall infrastructure, the data center. What happens if a hurricane comes through, or a flood, big fire, whatever, data center is knocked out. And so within each data center in Amazon, they call it an availability zone. They have redundant internet and power. So someone puts a backhoe through a fiber line, which does happen. They've got 10 more fiber. These guys are amazing. They've got 10 different fiber lines. Or power station blows up. They've got redundant power. Fine. This is old-fashioned data center stuff. We all get it. There's going to be redundancy inside a data center. A data center goes down. The concept in AWS is multiple availability zones close enough to each other that you can have synchronous replication between data centers. But once they get too far apart, then you've got to go asynchronous. That's a different story. But they've got synchronous replication between multiple data centers, and they each have their own redundant power also. Okay, fine, that's data centers. Next layer up, we've got the compute layer, servers and disks. So the beauty of the public cloud is that the storage is intrinsically mirrored and striped, and in fact, the engineering in AWS, they claim that they'll give you 5 nines of availability on a disk. Of course, if it fails that SLA, then you are doing a restore. So we'll talk about backups a little bit later. And if a server catches fire, which happens once in a while, server blows up, what do you do? In AWS, it's real easy. You stop a server, stop a virtual machine, start it again. Now it's on different physical hardware. Couldn't be easier. So just with that alone, before we go any further, a lot of the common failures that you're going to see, a failed motherboard, some blown up RAM, a disk failure, is already covered without any complexity. So if you did a vanilla SAP install on one of these servers, you already have most scenarios covered for high availability, and you don't even need to look at any further slides. But let's talk about some other components here. Fine, we know about Hana Replication. I'm going to be talking about Hana because we're at Sapphire. I'm not allowed to talk about any other database. So we're going to talk about Hana. But of course, all databases have some replication capabilities. But Hana has this baked in, and it's real easy. Anyone set up Hana Replication? Super easy. As a system administrator, I adore Hana stuff that takes a tremendous effort on other databases is easy. And we do HANA patches all the time, and we do Oracle patches for some customers, and I can tell you there's an order of magnitude difference in complexity. Hope Oracle's not too close, sorry Oracle. But anyways, love HANA replication. So you can do log shipping between availability zones very easily, and their availability zone bandwidth is extremely high, low latency, so you can have extremely low RPO, recovery point optimization in log shipping. SUSE has some features which you should ask them about. I'm not going to go into the muddy details, but just make sure you know about them, where they can do an automatic failover for you. So if a server goes down, the HANA failover happens for you. So it's automated clustering, baked right into SUSE Linux if you get their SUSE for SAP. It's amazing. So that means your recovery time on HANA is going to be basically how long does it take to do a HANA failover, which I would say we've gotten down to 4 minutes and pushing it down further. No one's been able to explain to me how to get it down to 1 minute yet, but we're all going to try to get there. The other components for all you SAP guys, we've got the so-called central services, right? Message server, NQ server. This kind of clustering is well understood in conventional data centers, but how do you do it in the public cloud? Because you're trying to do NQ failover between different availability zones at different data centers, and in AWS you can't float an IP address across availability zones. So how do you get your central services to move over? And SUSE has cracked the code using some esoteric Amazon features, some obvious features like Amazon has a shared NFS server, synchronously replicated. It's awesome. It's called Elastic File System. It's amazing. So you find you've got your shared storage, but they have a technique they call overlay IP address to get the IP address to move between availability zones using some routing table trickery. And they've got this all automated within their SUSE cluster, the same cluster features that you might use for your on-prem. High availability for application servers, I think, has been around since the mid-90s when SAP came out with their three-tier architecture. They had this baked in that, from the very beginning, high availability, redundancy of the application servers. And the only thing that is interesting about running in the public cloud is that you can spread these across availability zones in one region and still get excellent performance. There's no discernible performance penalty on your scale out across availability zones. So that means that you can have an entire data center take a dive, and you've got perfectly functioning application servers already. And finally, web dispatchers. You know, most applications today, including HANA, have built-in web dispatchers. But if you're going to engineer for pessimism, then you want to spread a couple web dispatchers across availability zones and then put a load balancer in front of them. Did I mention that AWS gives you a free SSL certificate if you run their load balancer? So finally you can stop paying through the nose, or worse yet, putting wildcard certs everywhere, which is a terrible practice. Amazon gives you a way out, free SSL certificates. So I just love it. So our goal as a service provider, we call our hosting service Seamless Systems, which is us running your SAP systems in public cloud. We use all these things I've talked about, Amazon features, SUSE Linux features, to give you high availability and redundancy in the cloud. Finally, and I have to emphasize again, this zero downtime patch, best feature ever, love it. So we might be toward the end here. We got, I mentioned backups. So of course you need to steel yourself against data corruption. Maybe someone deletes all the invoices in your system. Whoops, that's not a high availability issue. That's a recoverability issue. So you have to do backups. In Amazon, they have a storage called S3. You might have heard of it. Engineered for 99.9999999% durability. So your data is extremely safe out there. And it's pretty cheap, so you can store your backups for a long time. And finally, a couple additional topics. What happens if the whole eastern seaboard goes dark? Doesn't matter how many availability zones you have in Northern Virginia if no one has power. Now, if your company exists in the eastern region, then you're down too, and it doesn't really matter. But if you're a nationwide or a global company and you need you're going to be operating one way or another, whether the East Coast is live or not, you need to do cross-region high availability. I haven't talked about the techniques there, but those are available to do replication of your data outside of the region. Of course, you're going to pay transit costs, so there's fees there, but it can be addressed. Fine, okay, the final little sales pitch. If you want to go to the cloud and want to get there the easy way, we're the easy button. We can get your systems up fast, right in the public cloud. And I think that brings me to the end of my presentation. Did I run out the clock? I think we got time for a question or two. Good, beautiful.
Let's have him come up and talk to you. If you can stick around, John, for just a minute.
Yep.
If you do have questions for John, let's have you come up one-on-one.
Oh, do I get to do a drawing?
Yeah, you get to do
I've got the
drawing.
magic fingers.